Okay, good morning. Welcome to Math Project 71.
Cool.
Let's see. How's the problem go? The counting number has a remainder of 1 when divided by 3, and a remainder of 3 when divided by 5. Find the two smallest positive numbers with this property. Okay, so do you understand the problem?
Yeah.
What are we looking for? What are we trying to find?
These counting numbers.
And what property do they have?
With the remainder of 1 when divided by 3 and a remainder of 3 when divided by 5, and they can't be negative.
Okay, they can't be negative. Okay, so here's a purple. And how are you going to approach this problem?
Well, we can... Well, they aren't consecutive. They don't have to be consecutive.
No, they don't have to be consecutive. The only thing we know about them is they have a remainder of 1 when divided by 3 and a remainder of 3 when divided by 5.
We can call them x and y.
Okay, you could call them x and y.
But that trick usually works for consecutive counting numbers.
What else can you do on a problem like this?
Remainder of 1 when divided by 3 and 3. We need to find the smallest.
Yep.
We know what numbers that have a remainder of 1 when divided by 3.
Oh yeah, what are those?
Well, there's 4 and 7 and 10.
Okay, well why don't you write some of those down? Start over here. Start writing over on the side over here. I got it. I'll erase it. Start writing over there. 4.
4. We get 7. 10. And there's also 14.
You sure about that?
No, 14 isn't divisible by 3.
What are you looking for? What kind of numbers?
Well, I think 4, 7, and 10 are the only ones.
That have what?
The remainder of 1 when divided by 3.
No, that's not true. What's the next one that has a remainder of 1 when divided by 3?
13.
13. Not 14. 13. Keep going.
13. What else? Well, there's 17. 17 has what does it? Well, 16 isn't divisible by 3. Divisible by 2.
What's divisible by 3?
You know how. I know how they're divisible by. You know if they're divisible by 3 or not. The sum adds up to.
This one went with 3. This one went with 6. This one went with 9. This one went with 12. 4, 7, 10, 13.
This is going to be going with 15.
15, and what's it going to be?
16.
Okay, do you see the pattern in these numbers? 4, 7, 10, 13, 16? How do you figure out what the next one is?
You're counting by 3s.
You're counting by 3s. Okay, so what's the next one going to be here?
19.
19. Go ahead and write it. And what multiple of 3 does that go with?
Well,
18.
Yeah, 18, and then
21. So it's 22.
22, and then 25, and dot, dot, dot.
Uh-oh.
25 and dot, dot, dot.
You didn't write your 5 right. 22. 25. Yeah, keep going. Do a few more.
So, 25 goes to 24.
25 goes to 24.
And then 28.
Okay, and do one more.
Goes to 28 and then 31.
Okay, that's good. So, you wrote a bunch of numbers that have remainder 1 when divided by 3. And it turned out to be a little harder to do that than we thought, so that's why we wrote so many of them. But you see, once you start out with the first one, all you do is add 3 every time. So 4 plus 3 is 7.
Yeah.
7 plus 3 is 10. 10 plus 3 is 13. 13 plus 3 is 16. And 19, 22, 25, 28, 31. Okay, and we got to look at that list of numbers and figure out what do we have to figure out next.
Well, which one has a remainder of 3 when divided by 5?
Okay, which ones have a remainder 3 when divided by 5? Okay, so when you divide by 5, what kind of numbers have remainder 3 when you divide by 5?
Well, there's 3 and 8.
Okay, so 3, 8, what else? What numbers have remainder 3 when divided by 13?
And 18.
18.
So it just keeps 3, 8, 3, 8, 3, 8, 3, 8.
Okay, so what's the next one going to be?
23 and then 28.
23, 28.
And then 33 and 38.
33, 38. Okay, so these are the numbers that have remainder 3 when divided by 5, and we need to see if there's any that are the same in both lists.
Well, it says there should be 2 hiding.
Well, there might be. It says find the 2 smallest, so it's just a question if we made the list long enough. 13.
13, that's one of them.
That's one of them. That looks like it's the smallest one.
But do I have any 8s? Or 18s? Do I have any 23s? No. Oh, 28.
Look at that. 28.
13 and 28.
13 and 28.
And then the homework problem.
Well, yeah. A couple things, just to keep in mind for later on. Which one was easier to write out? Remainder 1 when divided by 3, or remainder 3 when divided by 5?
I think the set remainder 3 when divided by 5 because it's a pattern. 3, 8, 3, 8, 3, 8, 3, 8.
Right, it's an easy pattern. This one's a pattern too, by the way. You just add 3 every time.
But it's a more complicated
It's a slightly more complicated pattern. This pattern's easy. 3, 8, 3, 8, 3, 8. So whenever you're doing a problem like this about finding remainders, and you have a 5, right, use the 5s. Because the 5s are nice and simple to write out. Okay, and then one other thing I want to show you.
Yep.
I want to look at the difference between these two numbers. 28.
I think I know the difference.
What is it? 28 minus 13 is?
It's 15.
15. And what's 15 equal to?
5 times 3.
5 times 3. Isn't that interesting? That the 2 smallest numbers had a difference of 15, which was exactly 3 times 5, which was the 2 numbers in our problem. So what do you think the next number is going to be? That's going to have a remainder of 1 when divided by 3 and a remainder of 3 when divided by 5.
Well, it's probably going to have a difference of 15.
Okay, with 28. So it's going to be 28 plus 15.
What is 28 plus 15?
What is 28 plus 15? That's a good question.
I think it's 43.
Yeah. I think you're right. Does that have a remainder of 3 when divided by 5?
Yep.
And how would you be able to check if it has a remainder 1 when divided by 3?
Well, so the sum of the digits add up to 7.
Well, how do you, if this is going to have a remainder 1 when divided by 3, what number is going to be divisible by 3?
No, the number isn't going to be divisible by 3.
Right. If this has a remainder 1 when divided by 3,
I know.
what number will be divisible by 3? What number will have a remainder 0 when you divide by 3?
That goes with 42.
Right. So is 42 divisible by 3?
Yeah.
Please don't pick at the wall there, Cody.
Yeah.
Okay. Is 42 divisible by 3?
Yes.
How do you know?
The sum of the digits add up to something else is divisible by 3.
Yeah. Okay. Very good, sweetie. Good job today. Oops. Forgot the homework problem. It's Olympiad 72, problem number 1. Alright, very good.
Hey, I see the difference between 71 and 72. All math projects are catching up with the Olympiads.
Are they really? I think you're right.